We are interested in the history of devices and the history of technological capabilities and the trajectory of how our machines get more and more powerful. But historians of science are really interested not actually in the technologies themselves, but the worldviews, the paradigms, the contexts that those technologies represent, that they are responding to. And sometimes when we hear the history of AI, what we're told is that in 1956, in the summer at Dartmouth, as you saw in the beginning of my article, some engineers and mathematicians and logicians got together and came up with a program that would be called artificial intelligence. But I actually want to go even further back than the 1956 summer conference, the Cold War, the middle of the 20th century, to talk about where some of the dominant paradigmatic ideas about the world that allowed AI to make sense came from. This is a way of trying, in a sense, to see the water that we swim in a certain way. Can everybody see the slides all right? Great. So probably you weren't expecting this, but one of the important origin moments for what we call artificial intelligence is, according to historians, actually the French Revolution. So I want to go all the way back to the 1700s and say a few things about some of the dominant paradigms for thinking about the world that informed what AI is and how it works. So the French Revolution, probably you all know it as the origin of modern democracies, or as one of the important original moments where the absolute monarchy was overthrown and a new form of government was proposed in which the will of the people would drive the statecraft, the activities of the government. But a lot less known about the French Revolution is that we often call it, in history, we call it the engineers' revolution. There were so many engineers who came to be politicians, who were activists, who were organizing for the overthrow of the absolute monarchy. And engineers played a really big hand in reimagining what government would look like at all if it was to be driven by the will of the people. And the engineers believed that if you were going to have an effective state, an effective government that represented the will of the people, you were going to need a lot more information. So a huge undertaking as a part of the French Revolution was the gathering of new and way more information about the land, about state resources, about the population. They wanted better land surveys, calculated more accurately. They wanted to know how much land had been owned by the nobility, how it was going to be apportioned and distributed fairly. They wanted better measures of the wealth of the state, money that had been seized from the aristocracy. They wanted a whole lot more information about government. And the utopianism that shaped the French Revolution was, in a sense, an engineering utopianism. The very idea of democracy has been tied up with the belief that we need to engineer society according to the gathering of information about people, about resources, about culture. So maybe some of you know this, maybe some of you don't, but the metric system was essentially a product of the French Revolution. Prior to the metric system, and because you all are in the United States, there's some relics, ironically, of this older system. The idea behind the standardized weights and measures, the standard meter, the standard kilogram, the decimal system, the metric system, these were inventions of the engineers who architected the French Revolution. And actually, maybe I'll put this out as a question to you all. Any ideas why you think the French revolutionary government was so worried about things like meters and kilograms and standardizing measures? All guesses are good. All right, well, it's a good question. Oh, yeah, sorry, go ahead.
Is it political? Is it about where the power rests?
Yeah, absolutely. Those older imperial measurement systems like feet had tended to not be standardized. The foot used to be the measure of the current king's foot. There was an inherent subjectivity to the way that things were weighed and measured during the imperial absolute monarchy. And the French revolutionary government believed that in order to have a democracy, you would have to be rational, objective about governance. You couldn't have something like the length of the foot of the king determine how land was being measured or how people talked about weights and sizes. So the adoption of all of these standardized measures was a part of the drive to gather more accurate information, more standardized information. And the way that historians think about this period is that there was a moment where reasoning, the idea of reason, became the core guiding principle for the idea of the government. And reason was seen as the opposite of the absolute monarchy. The king was seen as a subjective tyrant who made decisions based on his whims, his vision, his experience, his ideas, and that was how the state was run. And so the engineers who were central to the French Revolution, they said, we can't have a government that's run subjectively according to the whims of this one person or this class of people. We need to be scientific and rational about the way that we run the state. And so the invention of these standardized weights and measures, this belief in gathering up huge amounts of information, was a central part of the very idea of democracy right at the beginning of the French Revolution. So ideas about reasoning and calculation were seen as totally essential to the project of self-governance. And that was seen in opposition to the whims of the monarchy that were seen as such a threat to the freedom and self-determination that people in France were fighting for. And actually, shortly after the French Revolution in Paris, they held what was called a massive festival of reason. They called it the Fête de Raison. And they paraded around Paris with these representations of what they thought reason looked like. So reason could be anthropomorphized as a Grecian woman who is paraded around Paris. There were paintings, there were monuments, there were treatises to the idea of reason that they thought would allow for a better politics. And one of the things that got paraded around in Paris during the Festival of Reason was a massive book of logarithmic tables that had been produced by Gaspard de Prony, who was a French mathematician at work during the French Revolution. So de Prony was a part of the standardization effort to make better informational tools for the French revolutionary government. And what he proposed to do was to improve the logarithmic calculations that were so central to doing engineering work at this time. The reason for it, I could get into it later, but the main reason for the value of logarithmic tables is that there are no calculators at this time, obviously. Nobody has a calculator to do any hard calculations for them. And it turns out that having these tables of logarithms simplified a lot of really difficult mathematical calculations. Instead of having to do hard calculations by hand on paper, you could look up the logarithms of numbers in a logarithmic table book, and that would allow you to simplify, especially multiplication and division. The identities for logarithms mean that instead of doing a really hard multiplication, you can actually do a sum of the logs of the numbers that you're trying to multiply, and these books of tables made that easier. So Gaspard de Prony said, okay, we have a whole new number system, we have a whole new decimal system, we have to recalculate all of our logarithms, and we have to do it with reason. We have to do it with reason so that our logarithms are more accurate, that they're more complete, and that we have better tools for doing the engineering work that we believe the state requires. So Gaspard de Prony started reading another book that maybe you all have heard of, namely The Wealth of Nations by Adam Smith. This is one of the inaugural texts outlining what we now call capitalism. And it espoused a belief that in order to advance the wealth of nations, we needed to be more accurate and more efficient and more mechanical about the way we process and deal with information. Adam Smith in this book wrote that only barbarous nations do things with their hands. He wanted to do things with machinery and attached that very idea of progress, accuracy, effective information management with capitalism and with the rejection of more traditional cultures that were invested in craft, hand labor. So built right into the very origins of capitalism is this belief that only barbarous people use their hands to do things, that they engage in craft, and that modern capitalist states will instead be rational. They will do things with machinery. They will do things as efficiently as possible, not as slow the way that handcrafts often are. And one of the central tenets of the wealth of nations, maybe you've heard of this idea before, was the idea of the principle of the division of labor. So Adam Smith said the way to be effective and efficient in manufacture, in industry, in running a nation is to take different tasks, identify the constituent steps that constitute the task, break it down into those constituent steps, and then you can execute it more efficiently by having one person in a repetitive way do the same task again and again and again, rather than having one person cut the wheat, dry the wheat, weave the wheat, construct the basket. One person would do one job only over and over and over, and that this division of labor, the breaking down of complex tasks into intermediate steps that people could do fast and easily, was also built in to some of these original ideas about what capitalist modern nation states would look like. So the mathematician Gaspard de Prony was reading Adam Smith on The Wealth of Nations, reading about the principle of the division of labor. And de Prony says, I wonder if we can apply the principle of the division of labor to the mind as well as to the body. What Adam Smith was describing was the division of labor for physical work. But de Prony said, I want to see if we can break down mental work, cognitive labor, into repetitive steps as well, so that we can be more efficient and more accurate and more rational about the way we solve mental and cognitive problems as well as physical problems. So in order to calculate these new logarithms for the festival of reason, Gaspard de Prony applied the division of labor to the process of calculating algorithms. And he came up with this pyramidal structure for how we might do mathematical calculations. Now, some of you probably know this, maybe some of you don't, but the word computer for most of its history did not refer to a machine. It referred to a person who did a certain type of calculating work for the government, for scientists in laboratories, and so on. And it was at this moment when Gaspard de Prony applied Adam Smith's principle of the division of labor to mathematical calculation that the very idea of a human computer emerged. In his pyramid, at the top would be the mathematicians. And what mathematicians do is look at something like a logarithmic calculation and figure out how to break it down into small, constitutive, more simple mathematical tasks that then the human computers who don't have very much mathematical education would be able to execute. So it turns out that within some fairly important constraints, logarithmic calculations can actually be broken down into series of additions. If you were my undergraduate students, you would then play the role of human computers at this point in the lecture and do the logarithmic calculations only by addition, but we don't have time for that today. But you get the basic idea that what it means to be a mathematician in this moment changes from them being the ones who solve mathematical problems to them being the ones who figure out how to get people to solve them by doing all kinds of additions. The analysts in the middle of this pyramid are the ones who set up any specific problem to be ready for the human computer. So the mathematician says, how in general can we solve logarithmic problems using only addition and subtraction? The analysts then say, okay, how do we solve this specific logarithmic problem using only addition? And they would do the work of setting up the initial values in these tables that the human computers would then fill in using only addition. And it's also at this moment that the division of labor as applied to the problem of calculation shifts the status of calculation. Before this method of breaking down calculation into small additions or simple parts, mathematicians were seen as geniuses because they could solve hard calculations. In the 1700s, you were called a genius if you could solve a hard calculation problem. But by the 19th century, solving calculation problems was seen as merely mechanical. And the human computers at the bottom of this pyramid tended to be women. Later, they were people of color. They were people who didn't have a good education, and they were paid very little. This was a moment when our mathematical calculations and our ability to process large amounts of information mathematically got sort of outsourced to a low-paid, low-status class of people who were seen as capable of doing menial mental labor, but who weren't intelligent or educated enough to understand mathematics. De Prony's tables were celebrated at the Festival of Reason. They were paraded around Paris as evidence of what this revolution in statecraft, making it about calculation and information and accuracy and rationality and the division of labor, could do. And one of the biggest fans of what de Prony had done in France was Charles Babbage, who is often called the grandfather of computers, who over in England was also reading Adam Smith and looking at de Prony's tables. And he said, I don't want humans on the bottom rung of that pyramid to be the human computers. He said, I wish to God these calculations had been executed by steam. And he was referring, of course, to the steam of the steam engine that was driving the Industrial Revolution across Europe at this time. And for Babbage, he wanted to replace those people at the bottom of the pyramid with mechanical machinery that could execute the additions and subtractions that were required to solve complex mathematical equations according to really basic constituent parts. So we can see the origin of computing and the origin of the belief that machinery is appropriate for processing information, for doing mathematical calculations, as a part of both the French Revolution's insistence that we govern according to information and the Industrial Revolution's desire to replace not just the labor of the body by machinery, like factories had done, but to replace the labor of the mind with machinery as well, so that we could be more profitable, more efficient, more optimized, and more oriented towards this rational vision of what the state might be. So Babbage wanted to do for mental labor what factory automation had done for physical labor, to make it as efficient as possible, to make it as rational as possible, as accurate as possible, and to apply to the mind the same principles of industrialization and capitalism that had been applied to the body in the context of factory industrialization. So he started work trying to build machinery that would replace the human computers at the bottom of this pyramid. His machinery was limited and failed, and famously, Babbage also was deeply resentful of the people who were working at the bottom of this pyramid, as well as those who were working in factories. He opposed the labor movement, called street people, street urchins, and criticized them for impinging on the mental work of the smarter people in society who were busy at work architecting these hierarchies that put most people at the bottom of the pyramid as mere factory workers or human computers executing the broken down division of labor that the managers and governors now had the power to dictate. So this is not the history of AI that you usually hear. And there's a big leap, and I'll say just a little bit about some of what comes in between. That the early history of AI, or the place that I identify its real origins, aren't the advent of modern digital computers. It's not 1956 at Dartmouth. I see AI as an extension of the application of factory logic to the human mind. How much of what constitutes thinking and intelligence can be broken down into these rule-bound algorithmic processes. Is thinking labor that we want to be made more efficient through factory management? I think that's a question still for me. It was taken entirely for granted in the 19th and early 20th centuries that thinking was something that we would want to do as efficiently, productively, and profitably as possible. But I think what's happening a little bit right now, especially in some of the backlash to the generative AIs and ChatGPT and related products, is that people want to reclaim thinking for inefficiency, for not the most profitable, most productive, most optimal, most industrial, most efficient application of industrial principles to our minds, right? But maybe thinking is something we want to hold on to for inefficiency, to not see it as labor. And that's a part of what the friction around certain AI systems has become. So just very briefly, and this is written in the article that you all read, so I can say a lot less about it, hopefully, but the big jump then that happened between this early industrial French revolutionary moment in the history of AI and the AI that we are more familiar with today was the Cold War. So the other really important element for understanding the origins of artificial intelligence is certain anxieties that developed during the US Cold War about the limitations of human beings. So as you all probably know, on the minds of everyone on Earth, for the most part, during the Cold War was a real fear of nuclear attack on the part of the Soviet Union or the United States. I think looking back, we don't necessarily want to acknowledge how real those fears were, but they were extremely real. This was a period where there was every possibility that a nuclear war between the US and the Soviet Union might begin, causing mass death, mass civilian death around the world. And there was a great deal of fear on the part of governments, militaries, civilians, for how to navigate that possibility and how to address it. There was a problem, of course, that emerged during the Cold War about all kinds of things. People are worried about the spread of different political ideologies. People are worried about the problem of global power. People are worried about the unfathomable death and destruction that could unfold if nuclear bombs were used. People were worried during the Cold War about the very real death and violence that were unfolding in places like Korea and Cuba and Vietnam. I tell my students the Cold War wasn't cold at all, of course. It was a very fatal time around the world. But there was another problem, another question that we hear less about than the threat of nuclear weapons that percolated through the American experience of the Cold War. And it is one that has a really significant impact on the history of computing and AI that has unfolded since. And it was this same question: how much of what people do can, must, or should be automated? And the Cold War raised fears that human beings were too slow, too limited to be trusted to maintain peace in such a complicated world. There was a huge amount of fear that human decision-making was too slow to retaliate in the requisite ways to a nuclear attack. Of course, the problem and the basic concept behind mutually assured destruction is that the Soviet Union won't launch nuclear weapons at the United States if it's guaranteed that the United States will retaliate in kind. And it was that détente that kept the powers from using nuclear weapons against each other. But in order for them to retaliate, in order for that retaliation to be feasible, decisions had to be made extremely quickly. They had to have tons of information about each other's nuclear arsenals. They had to know if they were under attack. You couldn't guarantee peace through mutually assured destruction if you couldn't know when or if your opponent was about to attack you with nuclear weapons. And the rise in investment in computers and artificial intelligence itself during the Cold War were both seen in part as ways of accounting for or accommodating what were seen as new human limitations in the face of an increasingly complicated world. So probably you've all learned this by now some way or other, but the first computers were built during the Second World War to replace the human computers who had been doing the calculated work for ballistics trajectories, for military calculating needs. The women who were doing those calculations as human computers were seen as too slow. And so the first modern digital computers were military creations that were built during World War II to replace and expedite that human computing labor. These first computers were military machines that were taking over for these vast hosts of human computers, hoping to make the world more safe by speeding up these different calculations that the human computers were doing. But at the same time, as I said, there was a lot of growing unease about the fact that people may not be equipped, not just to do the calculations of the war, but to make the decisions of the war. And so the idea that some sort of automation for decision-making had to be developed in order to speed up the sorts of decisions that diplomats, governments, and military officials had to make in this very complicated geopolitical situation. So I'll give you just one example to finish up of what this looked like during the Cold War and some of the ideals and ideologies that informed the belief that human decision-making should be automated as well. So the kind of canonical computer system of the Cold War was SAGE, the semi-automated ground environment. It was developed through a massive collaboration between MIT and its World War II Lincoln Laboratory, IBM, who built all the hardware, the Boeing Aircraft Company, and the US Air Force, as well as the Department of Defense. So if you've ever heard the phrase, the military industrial academic complex, this was it. This was industry, the military, and universities working together in service of a government mandate to improve American safety, I'll put in quotes, during the Cold War. So SAGE really embodied everything we've just been talking about. It was all about the gathering of information, the accurate stockpiling of information as a part of what they believed made the state rational and safe. It also represented the desire to offload decision-making power and prediction power from people to machinery because we did not trust ourselves during the Cold War. So SAGE was meant to detect inbound Soviet nuclear bombing planes and respond to them with the optimal deployment of the appropriate aircraft. And the idea was that if you could collect all of the radar data at all of the radar stations around the United States and its allies, put all of that data into the Whirlwind computer at MIT, and process all of that radar data, they believed they would be able to create a real-time image of the sky. And with their real-time radar created image of the sky, they hoped that they would be able to identify anomalies like inbound Soviet nuclear bomber planes. But they also wanted to automate the detection of enemy bombers from the anomalies on the screen. They said, well, humans can't deal with all this radar data at once, but neither can they even find anomalies once the computer has aggregated it. And then some people said it's not enough to have the computer identify the anomalies after it's created this real-time image of the sky. Maybe the computer should also scramble the fighter jets. What if the people are too slow, right? What if the people don't see? What if we are too limited? So SAGE became this site where military and political people debated just how much decision-making power should be offloaded to the computer. But it represented this faith that if you had the right data and you had enough data and you aggregated it in a powerful enough computer, it would be able to take away the uncertainty and the fear about decision-making, response times, retaliation, mutually assured destruction. It was meant to make us feel safe. And I think this is still true. I think that people who are excited about AI and machine learning are excited about it because they don't have faith in people. It's always presented as a way of bypassing human limitations. But like so many of the other technological systems that get celebrated and hyped as the silver bullet that will solve all of our problems and bypass human limitations and alleviate fear and concern, SAGE was a terrible failure. It cost $67 billion, and that is not adjusted for inflation in the 50s and 60s. That is an astronomical number. And it was obsolete before it was ever finished. And actually, it was never finished. It was obsolete for the reason that the entire thing was calibrated to detect the slow-moving, low-flying bomber planes that carried nuclear weapons. And very quickly, those were replaced with intercontinental ballistic missiles that this system was not calibrated, nor were any of the radar stations calibrated to detect. But nonetheless, in spite of these failures, at this moment, everybody gets excited that machines are going to think for us, that brains are going to speed up war problems, that brains, these artificial electronic brains, are outstripping man's capacities. The narrative started immediately to say that these things are better than us, they're faster than us, they're more accurate than us, they're going to think for us, they're going to solve problems we can't solve, they're going to keep us safe when we're not safe. And I see so much of the history of AI as just this desperate desire for a machine that gets us out of the problems of being human or the problems of uncertainty that we handle today. It was in the context of these anxieties about human decision-making capacity, media hype about computation, and the Cold War that article of mine you read begins, with the advent of what's called artificial intelligence. Even back then, some people were not excited about this, as you can imagine. We could talk a little bit if you're interested in some of the angles of critique that were lobbied at these attempts to automate mental labor, to offload human decision-making. And of course, a lot has changed, but some things have not changed. And I would love to hear from you all, because you're living through this moment of the advent of generative AI successes, quote unquote. And I'm curious what concerns or anxieties you think those systems are responding to. Because we can talk a lot about what their capacities are, what they can and cannot do, how they do and do not work. But I'm more interested in what people think they're good for and what exactly they're responding to contextually in the way that these histories of industrialization and capitalism and the Cold War might sort of help to inform. So I'll stop there. I think we've got like 20 minutes left. I'd be happy to talk about that story, the article, AI today, whatever is of interest. But I think the important takeaways are that AI is not some new idea, but it participates in these much older, centuries-long historical trajectories around industrialization, the desire for efficiency, the lack of faith in human decision-making, our desire to process huge amounts of information as an epistemology. And we can track those trajectories much further back than the digital computer, than AI. And I think we still see some of those dynamics unfolding around us today.
Obviously, we wish she's here so she can answer the questions now. But this was the question posed by students, and I saw that her answer was fabulous. And for another 20 minutes, you will see how she responds to a variety of questions.
I love to think about the future. So I will say that I can't, from this moment, predict where we're headed. But I could say something about where I hope we're headed. Or what kinds of avenues I think are really rich for the development of new technology. And I'm really excited about a field that sort of emerged in opposition to artificial intelligence that was called, in the second half of the 20th century, HCI. Maybe you've heard this term, but human-computer interaction as a sort of alternative site to artificial intelligence. And the basic difference was that artificial intelligence was always oriented around creating standalone, autonomous, intelligent machines. So machines that without us, after we programmed them and set them up and given them their data, can go on their merry way, solving problems, making decisions, giving us answers. They are intelligent on their own. But historians of science don't actually believe in this vision of intelligence as something that inheres in an autonomous individual alone. We see intelligence as a function of collectives, right? Intelligence is what we can do together. Intelligence is relative, it's social, it's changing. And HCI said, we don't want to make computers to replace people. We would like to make computers that augment human understanding, not take it away. We want to build technology that enriches human life, not closes it down. And there has been a bit in some of the backlash to contemporary AI, a resurgence of interest in human-computer interaction. And I'm really interested to see what comes out of those research trajectories. The people who are saying, let's not make a computer that just does stuff for us. What would it look like to design technology that does stuff with us in ways that augment our experience of being human? And it's not about us being too dumb, too slow, too inefficient. We have to work against ourselves all the time. It's like, what if we embraced the human condition and built technology that allowed us to flourish in it? And that's an avenue that I think could be both very profitable, because I know that's an incentive structure we have to consider, but also possibly far more enriching and a little bit less terrifying than some of the AI development. So that's something I hope to see. It's such a great point. You've got some history of science cred of your own, I see. Yeah, it's an incredible point, and I think you're absolutely right. The COVID pandemic, I mean, I wouldn't ever say the words, well, I'm about to say them, but I wouldn't say them and mean them, that I'm grateful for it, because there's nothing to be grateful for. But I do think that many of us, if not most of us, had been sort of trucking along with the belief, because this is what we're told, right? With the belief the scientists have it in hand, right? That everything is taken care of, we have the data, the governments are looking at the problems, we are able to deal with all of these issues. And COVID brought the world to its knees, right? It brought modern science to its knees. And part of the reason, as you've just identified, is that we did not agree about how to address it. And there was disagreement, and politically motivated and ideologically motivated disagreement about how to respond. And this, I think, raises a really important point. The absolute highest award in the history of science world is the George Sarton Award. And this year, the Sarton Award, the Sarton Medal, is going to a totally tremendous historian by the name of Theodore Porter. And Ted Porter is our sort of inaugural historian of quantification. He writes about why we quantify, how we quantify, when we quantify. And he made this really astonishing argument in his most foundational book, Trust in Numbers, where he said, you know, we don't reach for numbers to solve disputes. We quantify so that we don't have to solve disputes and disagreements. We reach for numbers to bypass the harder job of actually making ourselves agree. And when I first read that, I thought, no, we put the numbers on the table so that we can agree or disagree about what is going on. And he said, by the time you're reaching for numbers, you've already forfeited the disagreement. The data doesn't resolve the disagreement. It's meant to bypass the disagreement. And I think I see this now happening all of the time, where parties who disagree, like people who want vaccines and people who don't want vaccines, they disagree, and we bring in the data in hopes that it will resolve the disagreement. But what it's actually doing is saying, actually, we're not going to talk about the disagreement. We're just going to try and establish the fact. And numbers are an attempt to establish the fact, but they don't actually allow us to solve what are essentially ideological differences. And we now know that. We're living basically with 2 centuries now of not actually solving disagreements, and instead just trying to put facts on the table that mean we don't have to solve them. But those disagreements have always been there, and they're going to continue to be there. And we know that the data don't solve the disagreements, and we need other actual political and social mechanisms for navigating these chasms that have emerged between different perspectives. And the data itself does not solve the disagreement, because the disagreement isn't about the facts, it's about the ideologies, right? And so I think quantification is a very fraught bedfellow with democracy. We know from the French Revolution that the belief was, with enough information, the right information, with rational governance, we can represent the conflicting and conflicted will of the people at the level of government. But it turns out it's much harder than we think to navigate these things. There's a paper that I love by an anthropologist called Margaret Mead that she wrote in 1936 that's called "Are Democracy and Social Science Compatible Each with Each?" And she basically says, okay, we know, so this is the 1930s, everyone in the social sciences is worried about fascism. So she says, okay, we're worried about fascism. We're worried about the rise of the Nazi Party in Germany. We're worried about the rise of fascism in the United States. We know that fascism is a project of social engineering. It's a project of making people think and feel a certain way through propaganda, through education, through statecraft, through state media, through oration, control over information, censorship. We know that fascism is about engineering people into these disciplined modes. But then she says, I'm pretty sure actually democracy is the same. She says democracy is also a project of social engineering. We're not born good at democracy. You have to similarly engineer people to be tolerant, to be open-minded, to have a certain sensibility about pluralism, to have a certain sensibility about tolerance, and so on. And then she says, but if both fascism and democracy are just engineering projects, what makes them different? If you're the engineer and you're the one trying to create people the way you want them to be, to act the way you want them to act, that's not so far from what we think fascism is. And the other thing she says in that paper that I find so interesting is she says that, from the French Revolution onward, democratic government was supposed to be two things. It was supposed to represent the will of the people, but it was also supposed to be rational and scientific driven and based on information. But what do you do when the will of the people and the dictates of the science and the information are in conflict? And that was a problem at the inauguration of the French Revolution. It was a problem in the 1930s when people were worried about the rise of fascism. And it's definitely a problem today, both where people, for example, who hold really right-wing conservative positions in the United States believe that the liberal government is trying to engineer them in a fascist way to believe things they don't believe, right? And they also don't accept the dictates of the science around which COVID was meant to be managed, or the climate catastrophe is meant to be responded to. So we're still stuck with some of these really original tensions at the heart of the democratic project. Is information going to solve all the problems for us? Are we going to have the right data and then we can run an efficient government? All of those utopian ideals that I think are very much enshrined in modern AI just bypass the part where we're people all together and where people have ideological commitments, they have religious commitments, they have commitments that aren't about quantification. And so I think you're exactly right to make this connection between this history of AI that I'm trying to share with you and some of the things that happened during COVID. And it's all just a lesson in the fact that technologies don't solve hard social problems for us. They don't. They can help us, but solving hard social problems is always a social and political undertaking, I think. And we wish so much that it didn't have to be, because that's so much harder. It's so much harder to actually have to figure out how to solve disagreements than it is to just say, here are the facts, right? And so I think we're still dealing with a lot of this stuff. do the science, but never see it as the only work that needs doing, but to see how can it work together with the political and social initiatives that we know have made change in the past. It's like, that's such a great example about the eclipse measurements. It's a perfect example. And yeah, I think the more you look, the more that's what you see. It's like, just a closing thought, the historical canon used to say that in the 15th century, Gutenberg invented the printing press, and then that caused the secularization of Europe, the modernization of institutions, the democratization of information, because it became cheaper and faster to produce printed word, and so more people could read and write and whatever. And the truth is that it was more than 300 years later that more than 50% of Europeans could read. So this story that the printing press democratized information ignores entirely the fact that only a tiny part of the population could access that information. And the real revolution of Europe was not the printing press, it was the 250 years that people were fighting for public education and for the idea that people should be able to learn and read and become literate. And they could not have done that without the printing press. The printing press was an essential handmaiden to this political movement to advocate for public education for everyone. But we then flip the story and say it was the printing press that did that work, not those people who fought for centuries for expanded literacy rights across Europe. And I think we need to do that flip again, where we should see technology as serving social and political work, not replacing it or bypassing it or getting up above it, because it never does that. It's never done that. So that's a perfect analogy and a really great observation.